Hello, welcome back. So in today's video lecture we will talk about the ResNet architecture, which is going to use in the transfer learning. Here we are having the transfer learning, and this transfer learning is used in various applications part, like what is the ResNet architecture we will discuss over there. Okay, so ResNet architecture is having basic, like it's a kind of transfer learning, and it's a pre-trained deep learning neural networks for binary classification. So we already know what's the classification and what's the regression. So here we are talking about classification between 0 and 1. I have taken example. Two classes are there, O and 1. All right, so we are going to classify different sections, different objects in between O and 1. So basic concept here, like what's the input over there and what's the weight layer, and across the ReLU, which is the activation function, and we are going to pass the next weight layer. But we are going to discuss that concept in the ResNet architecture, that it's having that jump over here. You can see this jump is going to add here whatever the input value there and whatever the function there, that is going to add up here, and then next move towards the next layer. So this is the X is the identity, and this input value is going to jump, because once we are going to increase the number of layers, it's not sure that we are having the best result or optimal values or optimal output. All right, so what's the basic definition of ResNet 50? Why we are including this 5O term, I'm going to discuss next. So ResNet 50 is not the first model coming from the ResNet family. The original model was called Residual Net, all right, or ResNet, and was another milestone in the CV domain back in 2015, and the ResNet model, which is convolutional neural network with 50 layers. All right, so we are having 50 layers in this text, and these 50 text and 50 layers are going to define in so many layers, in so many patterns over there. All right, so we are going to explain what's the next part of this one. So you can see that ResNet network is one of the famous it's one of the famous deep learning models actually. All right, so this deep learning model is going to define in terms of various architecture, in terms of various terms, like it was introduced by Shang King, Ren, Kemin Wen, and Zhua Sun and Jianggu Zhang in their paper. The paper was named Deep Residual Learning for Image Recognition in 2015. So the ResNet model is one of the popular and most successful deep learning model so far. All right, so this is the layers in ResNet 50. All right, so we each layer is having significant role. Here we are having means in context we are having 5 convolutional layers in the network. All right, so these are 50 CNN neural network layers inside the networks. So 50 means 50 CNN layers are there. So previously we had AlexNet. So this AlexNet had 18 layers, 8 layers, I'm sorry, not 18, it had 8 layers previously. VGG net, when we talk about the VGG net, which is most widely used in the deep learning, it's having 16 layers. It was having 16 layers previously, 16 convolutional neural network. When we are talking about Google net, which was introduced by Google itself, it was having 22 layers. All right. So 22 layers and VGG with weights is equal to ImageNet and Inception version 3, and so many architectures are there. So you can see in these 3, 1, 2, 3 and multiple of 3 means these one pair, second pair and 3. So how many layers are there? These are 3 3 9. So 9 layers are there. You can see like 9 layers will be there, and then we are having 4 pair of 1 2 3. So the 1 cross 1 convolution, 3 cross 3 convolution and 1 cross 1 and 512. What is the 512 here? That is the ResNet first introduced concept of skip connection, and add this original input to the output of the convolution block. All right. So we are having the shape of the image here. All right. So 4 into 3, what is the value here? That is 12, and 6 into 3 pair. You can see 1 2 3 pair, and 6 into 3, that is 18. All right. So okay, one more time I'm going to clear all these 3 so that we can have the crystal clear image of these architectures. All right, great. So here we are having 3 into 3, that is 9 convolution layers, 4 into 3, that is 12, and 6 into 3, that is 18, and 3 into 3, that is 9. And how many pairs are there? Like this is total 30, and 9 9 18. So 30 plus 18, that is 48, plus when we add up these two values, and here we are having one soft mix and one pooling layer, and here we are having one pooling layer also. So we will add up these two layers also. So this will add up 1 and 2 layers, that is going to depict 50 layers. And in this architecture they are going to predict 7 classes. All right. So these are the skin diseases, and skin diseases are going to input in this manner, and going to classify in the 7 layers. All right. So coming next, so here we are having example of chest X-ray image input, which is having 100 cross 100 resolution in terms of pixels, and 3. All right. So what is the 3 here? That is the RGB. So it's a color image. So we are having RGB. So 3 channel is there, and it is going to define here. And again, this is 9. This is 4 3 is 12, and 6 3 is 18. 3 3 is 9, and then one more layer here, and then one more layer here. So when we add up all these value, 1 plus 9 10, and then 22, then 40, and then 50. So add up we would get 50, and this layer is going to predict COVID-19, viral pneumonia, and normal patients X-ray images. All right. So coming next, layers in ResNet 50. So deep residual networks, like the popular ResNet model, is a convolution neural network that is 50 layers deep. A residual network, ResNet, is an artificial neural network of a kind that stacks residual blocks on top of each other to form a network. All right. So what is the project ideas in terms of ResNet? All right. So when we talk about the ResNet, which is the binary classification, so we can, for autonomous vehicle trajectory predictions, we can predict these the trajectory paths for the autonomous vehicles. Those are not having drivers itself. Extracting spatial temporal features. So spatial temporal features means we are going to extracting the features of the particular images or voice. So it is used over there. Autonomous car motion prediction, it is going to predict the motion of the car or the vehicle. Binary classification of COVID-19 CT scans. All right. So it is having COVID-19 CT scans over there. So different problems related to image recognition, object detection, face recognition, and image classification. ResNet is used most widely in terms of deep learning. All right. So you can play around for these ideas. All right, so what's the architecture, what's the different? So a regular block, you can see in the left side, it's having activation function. Okay, we are having input over here, and then we are having wait layer, then we are having activation function, then we are having wait, and then we are having function. But here we are going to jump from this point to this point, and this is going to subtract the function, and here we are going to, if it is not the value x, so here we are going to add up. So automatically fx plus x minus x would be equal to fx itself. So that would be the feedback or the input to the activation function next. All right, so these are other ResNet, like what's the other models there, like VGG16s are in the existing, Google Net is there, which is having 44 layers. So pre-LU net is there, plain 35, ResNet 34A, 34B, 34C, and ResNet 50, and there is ResNet 101 also. So we are also having 152 layers also. So you can see that it's having that error also, it's showing that error, so it's having least error. So error rates is 10% crop testing and ImageNet validation. VGG60 is based on our results. So this is the result given by the given research paper. Okay, so what's the feature of ResNet? It just won first place in the ILS VRC 2050. It's kind of competition. So in that competition, it just won that first place classification competition with top 5, error rate 3.57 and an ensemble model. All right, so won the first place in say in COCO 2015 competition in ImageNet detection and ImageNet localization. All right, so COCO detection and COCO segmentation, replacing VGG 16 layers in faster RCCN with ResNet 101. So they observe relatively improvement of 28%. So this is the big number for training. So efficiently trained networks with 100 layers and 1000 layers also. All right, so these are few research works or the paper, you can say that how we are going to collect that part and how we are going to collect that research paper and so on. And then good luck, thank you. You can subscribe, you can like this video, or you can have the any doubt, you can mail me anytime. The description box is having all my contact details, and you can ask how we can deploy this ResNet for our binary classification in deep learning. Thank you very much.